Well, welcome everyone. This is the DroneCode talk. For those of you that went to the keynote, this is going to be like a more in-depth description and overview of what the drones were actually doing. Like, I know the keynote was super high level and I was oversimplifying most of the things. And yeah, so more about myself. For those of you that were in the talk this morning, I'm the general manager for DroneCode Foundation. And I'm also one of the maintainers of PX4 and some of the other projects. I've been working for 13 years in drones. Before this role in DroneCode, I was doing robotics at 3D Robotics in Berkeley, California. We were the first company to do a smart drone. And yeah, so glad to be here. I also co-lead the Ross Aerial Robotics community work group or interest group. They keep changing the name of what it should be called, but yeah. And also co-leading the Space Grid Linux thing. Yeah, awesome shirt. There's only one shirt, so we don't have more. I'll make more available, and I'll share them on the next Open Source Summit. All right, so who knows about DroneCode here? Anyone? 2, 3, awesome. All right, so DroneCode's been around for 10 years now. We got a global community of more than 13,000 developers. So it's not just me and like the other guys in their garage. There's actually tons of them. 13,000 actually contributors, not just users, like people that have contributed to some of the more than 100 repositories that we have. So we've been around, we're being used out there, and it's also being used in production. Did I have this? Oh. I repeated the slide. Here we go. We have a good member community. These are companies that are actually getting memberships in DroneCode. So if you want to support us, the best way is to get a membership or contributing. Like any other Linux Foundation project, we're focusing on providing benefit and value to companies so that they can build on top of the open source projects. This is a good slide. Actually, this is the list of the top projects of the Linux Foundation, and we're in 16th place right there. Like, who celebrates 16th place, right? But we're an embedded robotics niche project, so it's like a lot of work to get there. Other projects that are up there are Zephyr, Node.js, Kubernetes, so we're like really proud to be there. This data is coming out of LFX Insights. For those of you that don't know, it's a really cool website that actually aggregates all of the analytics for all of the open source projects within the Linux Foundation. And I think we're starting to diversify outside of the Linux Foundation. Let's see. I guess the best stat here is like almost 60 million lines of code. It's a lot. Yeah, 13,000 contributions over time. All right, so what does it actually look like, or what are the actual products? How do you actually find this out there? I've been passing around flight controllers through the room, so if you haven't seen them, they'll get to you. These are basically the brains of the drone. This is what actually controls a drone, and it's like running inside a microcontroller. These are some of the products, not all of them, that are running PX4 or any of the open source technologies. All right, so what are some of the examples? This is Walmart doing drone delivery using open source. I showed this morning. It's vertical takeoff and landing for a company in Switzerland. It's called Wingtra. This is the Alta X. This is a cinematography drone that carries a payload that is way more expensive than a drone, like a $100,000 camera with a great lens, and the drone has to be very reliable to handle this. This is out of Germany, Quantum Systems. They have a model platform that actually can switch around. Underwater vehicles too, like we mentioned this morning. It's also running PX4. Quadcopters for swarms. So this company out of Korea is doing drone light shows. And yes, this too. Sticks. Drone out of sticks, and it can run PX4 as well, and it actually flies. I failed to capture the video. Someone posted this on Twitter, and X, and I grabbed it out of there. So I thought it would be funny, but it's kind of dull to watch pictures, right? So I got videos this time. See if it autoplays. This is an example of an advanced drone. It's an omnicopter. You cannot tell which side is in front of it. I've been to this point, I've been working in drones for like 10 years already. And when I saw this video, I got chills. Like, it was very, very new to me. It's something that I have never seen. I didn't even thought it was possible. But look at the way it moves. It's like a spaceship. It's just moving in a direction. I'm going to keep it playing because it does some really good motions. Some of you might already seen this video, but we have documentation actually how you build one on our docs. So if you want to do this, you can. It's not that hard. So it'll just cost you a bit of money because there's quite a few hardware. It's a quick screenshot of what it's actually executing, like the mission, the orbit. Yep. All right, so that's kind of cool. This is a company out of San Diego. Is it? Yes. Model AI. This is actually the vehicle that I showed in the keynote this morning. This is what it's actually capable of. So it's like visual inertial odometry. So taking the location, assuming the location from the video and the IMU to be able to map the room. As you can see, it'll navigate safely across the room, which has quite a few obstacles. It's an office space, so it's not like they made this, they faked it. I'm going to let it play a few seconds more. One more video. This is a company out of Germany. It's called Sunflower Labs. They're doing security drones. This is more of a marketing video, so I'm not going to let it play too much, but I want to speak over it so we can see the actual usefulness of the video, the drone, sorry. They're actually having a security system that has detectors on the ground, and if it detects someone, it'll launch a drone that is actually living in a box in your house, and it'll just launch a drone and like try to find what actually triggered the motion. If you're really paranoid about home security. But it's kind of cool. It's a really cool product, and it's also enabled by PX4. All right, too much marketing. Let's see what's next. Oh, my favorite, drone light show with fireworks. Yeah, most of the drone light shows that you will see out there are likely running PX4. This is a company called Sky Elements, but they don't produce their own drones. They buy them from a company in South Korea, South Korea called UBFi. They produce the UBFi IFO, which is running PX4, and it's a drone made exclusively for drone light shows. Some of these are like swarms for up to 1,000 drones. And they just added the fireworks because it's so cool. So you can like do really cool stuff with this. Should I continue? You want to see all the video? All of this you can find it on YouTube, by the way. Have anyone seen a drone light show before? No? Yeah? Is it cool or not? Yeah, right? Like the first time you see it is like mind-blowing. This is the second time I got chills when I saw, the third time. First one is when I actually saw the first drone. This is the second time, and then the third time was the other drone that I showed you, the Omnicopter. It's rare to see something so innovative that it actually causes you to have an emotional reaction. This was one of those. And then recently on the last PX4 release, we enabled rover support. Well, advanced rover support. We already had it, but this is a Mecanum rover. You'll see the motion is a bit different than a normal rover. If it hurries up, it's kind of slow. Here, there you go. I think this is executing a mission, so there was waypoints, and the drone is following the waypoints. Well, the rover. Kind of boring. Here we go. This is another one. This is the Ion Robotics R1, I think. This is also executing a mission, so just going through the waypoints and like doing a motion. All of it running PX4. This is another one. This is running this out there in Sky node. Actually, all of the rovers were running the out there in Sky node. This is a bit better, as you can see, more natural motion. All right, enough videos? No, last one. Oh, this is collision prevention with the rover. So it's gonna try to hit the backpack. It's avoiding it. Ba-bum. There you go, success. All right, and last but not least, the full video that we saw this morning, just in case you wanted to actually see it. This is a company called Carbus Robotics out of Silicon Valley. They're actually doing inventory scanning. This is a really cool drone. See if I can fast forward. Because I don't think I played the whole video in the morning, and it's kind of cool. I promise this is the last video. But it's kind of boring if I talk about drones and I show you what I do, right? All right, I think that's it. All right, so what it's actually enabling all of this is the DroneCode stack. We got the PX4 autopilot, the Pixhawk project, which is the flight controllers that I've been passing around, MAVLink, MAVSDK, QGroundControl. So I'm going to be talking a little bit about PX4 and the rest of them and how they actually relate to the things that we just saw on screen. All right, so this is a development kit. This is another development kit similar to what we saw this morning. This is the DEXI. This also is a PX4 development kit. So I've been working as part of DroneCode with manufacturers to actually release development kits that actually run PXR upstream. So they run natively all the open source project. So that developers should expect the same developer experience on each of these platforms. It doesn't matter what they are. It's taken a little bit of work handling that with the manufacturers, but it's been very rewarding because now if you want to try PX4, you can actually just go and buy a development kit and we'll just have a similar development experience, which, to be honest, wasn't the case until now. This is what a modern drone looks like. So you got a bunch of sensors on the drone, and you got a handheld controller. It's usually like an Android tablet with sticks, and there's some kind of telemetry in between. So let's talk about the main components on a drone. This is basically the flight controller. So on the left, you got I think this is the ARC B6X flight controller, similar to what I've been passing around. If you see the flight controller that I've been passing around, it has actually a module on top, some of them. Well, it's modular, so manufacturers can actually create different baseboards. This is one of them. It actually also has support to connect an NVIDIA Jetson or an NX into it. So essentially, you get the microcontroller, and you also have the NVIDIA Jetson in it, so be able to run advanced autonomy, typically RTOS. How do you connect to it? You got drone. Some of them have 5G. Some of them have Wi-Fi. Some of them is just pure RC. It's rare these days that it's pure RC. And then the protocols is typically CNO, DDS, or MAVLink. And then the video one. This is the ugliest slide I have, I promise. I made this. So this actually explains what's actually going on with all the open source projects. So you got the vehicle, which is encompassing the whole thing. And then inside, you got the PX4 flight controller running on top of the RTOS and the flight controller. Then on the mission computer, you got certain protocols depending on what you're trying to do. I'm not going to spend much time here because I'm going to explain it with this one. This is the same slide you saw this morning, but I want to reiterate here what's going on. So PX4 runs on top of an RTOS. Which RTOS? Apache Nautic. That's what we've been running for the last 10 years. We've been one of the top contributors to Apache Nautic. Nowadays, some of the members actually want to push for Zephyr, and we're working hopefully to get it done soon. There's already ported, I think NXP already ported their hardware to work with Zephyr. We just haven't ported PX4 to Zephyr yet. And then on top of the RTOS and the flight controller, you got a collection of sensors. So basically PX4 is running on top of the RTOS, grabbing data from the sensors, and then putting that through the middleware, and there's different modules that actually control the vehicle. All right, so which type of vehicles do we support? You already saw most of them, but we also support jetpacks and satellites, balloons, boats, Basically, everything that's a mobile robot can be controlled with PX4. But to be honest, the one that we are like known for are aerial vehicles, drones, quadcopters, hexacopters, and all type of configuration of multicopters. What's cool about PX4 is that we actually think of it as a development stack. What that means is that the interface is made so that you actually can build on top of it. We have a BSD3 license, which actually means that anyone can just take it, right? So how do we actually incentivize people to contribute back? Well, by continuously evolving the interfaces and making sure that the code base remains clean for them to be able to contribute back. Hi, Kim. And then one of the other cool things that we do is we have a really cool control allocation engine, which means that you can translate thrust and torque commands into actuator commands without actually having to know the geometry of the vehicle, which means you can actually have the same control structure run on all of the different vehicle types, which is pretty cool. This is what it actually looks like. It's a bunch of mess in here. It's like different modules that are interconnected to each other through the middleware, because we call it UORP, microORP. All right, we have a system storage inside of PX4, a database. Obviously, we need to store some of the state of the vehicle. We have logging. We have parameters, which I'll show you in the next slide. We have driver support, obviously GPSs, RTKs, airspeeds, IMUs, barometers, gyroscopes, all of it. We got, last time I grabbed the drivers folder, it was like more than 100 different sensors. We have two external interfaces. One of them is MAVLink, which is one of the other projects that is hosted under DroneCode. And then we also have, right now, XRC DDS. And as of last week, thanks to Peter right there, we have Xeno support. And yeah, so we have basically a state machine that is controlling the whole thing. And one of the cool things is that we have parameter support. So if you're a developer that wants to extend the behavior of PX4, but maybe you want to set a parameter that the end user wants to see. For example, if you're going to take off, the question would be, what altitude are you going to take off at? So how do you actually extend that to the user, a pilot that might not be a developer? You don't want them to actually modify the code, right? So we do that through a parameter that we send all the way to the mission control application. This is just a screenshot of different parameters. You can search for them, you can modify them, and you can, as a developer, extend your modules like this. Some of them are more advanced, like battery control and all that. There's a bunch of parameters, so it didn't make sense for me to put all of them. So the middleware. All right, so we say it's DDS-like because it's very compatible, but it's not DDS, not by any means. We basically push almost everything through that middleware. You can get access to all of the state estimation, all the control, everything that goes through the pipe, you can get access to it. There's priority control on there. So you can say, oh, I want this at a higher rate than any other message. And through the ROS interface, the DDS interface, you can actually now, on Linux side, on a different computer, you can actually now grab directly from the middleware that is controlling PX4 in the microcontroller. You can grab that data. How does it actually look like? Like this. Like everything's connected to each other, all the modules and sensors and everything is actually talking to the middleware. It looks like a mess. I know, it's sad. Don't look at this. All right, we have different flight modes. These are like the modes where you can actually fly with the sticks, with the drone. I think the most notable here is the mission mode, where we actually execute waypoints on PX4. Like I've been saying, we got ROS2 support. This is a slide on how we do it through the DDS layer. We have all the UORP topics, and we map them to DDS, the macro, push them through the macro DDS bridge all the way to the DDS agent on the other side. You can connect the microcontroller to the like the Jetson through either Ethernet or serial, and then on the other side you can grab that and push it through a ROS node. All right, one really cool thing that this enables is that you can now rewrite the behavior of PX4 running on the microcontroller, but on Linux side, on ROS with ROS2, which will enable you to actually override some of the main behavior like return to landing or like takeoff or any of the missions that we have before, or you can even add new ones, which means that if you have a new mode running on Linux, if it ever fails this is going to catch it and it's going to activate the failsafe back on PX4. So if you, for any chance, let's say, modify the return to landing behavior to do, I don't know, like maybe return to landing with obstacle avoidance because there's, I don't know, an environment with heavy obstacles. And then, I don't know, Linux restarts, anything happens, then the PX4 on the microcontroller is going to take over and is going to notice, hey, I'm not connected to the Linux computer anymore. Something's happened. I'm going to take over with the basic RTL behavior and I'm going to try to land the drone. So you're sure that your the PX4 is going to have your back. And yes, like Mary, we do support simulation. The base default simulator right now is Gazebo. But we do support other simulators like FlightGear, JMapSim, AirSim, ISACSim, basically all the simulators out there. The one that's more stable is Gazebo, I would say. But I pretty much have used all of them before. This is like a quick example of obstacle avoidance. Sometimes developers, when they send the pull request, they send a small screenshot of the simulation. All right, so where do we actually run on the hardware? We do support RISC-V, thanks to a company called TII, one of the DroneCode members. But we mostly run on ARM architecture. Like the hardware that you've been seeing is basically an STM32 or an IMX RT1175 and 76. I got it right. Like I said, not XRTOS. Hopefully Zephyr coming soon. So if any Zephyr developers in the room want to help us, please reach out. All right, hardware-wise, what's going on in the hardware-wise? So the PX4 Autopilot project started 14 years ago out of ETH Zurich, out of the necessity of having to fly a drone, create a drone. Actually, this guy wanted to do his, I think, a master's with computer vision on a drone, because computer vision 14 years ago wasn't enough. He wanted to put it on a drone. There was nothing out there, so he put together the first spec of open hardware. And he built Pixhawk. And then in order to be able to control Pixhawk, he created PX4. Fast forward 14 years now, it's been a ton of hardware supported. This is a good slide. So 16 years now. All different versions of Pixhawk. All the modern ones are not here. I've been passing around these two. Let's return to this one. Yeah. So PX4 also runs on Snapdragon Qualcomm. The drone that we featured this morning on the keynote is actually running Qualcomm RB5. And Pixhawk has evolved into way more than flight controllers. We also have standards for gimbals, for debuggers, for connectors, everything that has to do around hardware. We're trying to standardize together with member companies of DroneCode, partners of DroneCode from the industry. And actually, we don't actually manufacture all this. We put together the open hardware designs, and then we work with the manufacturer to actually build those. Up until the last version of Pixhawk, the sixth generation, we were open hardware. And the sixth one, we moved away from open hardware. We had a big issue, which was basically a lot of people used the open hardware schematics. They changed sensors, they changed rotation, they changed components, and they still called it a Pixhawk. And then the users would obviously assume that it should just run with PX4, but the firmware obviously needed to know how to handle the changes in the hardware. So what happened? We got a bunch of support requests on the GitHub about, hey, my hardware doesn't run. And then they shared the logs, and we figured out, oh, this is not a Pixhawk. What are you trying to do? So we have to support all of that. And the support for the maintainers was too much. So what we did is we changed to an open standards approach where we actually only share the pinout. And it's actually been very successful. A lot of manufacturers have created designs based on the open standard. But for the DroneCode members, we actually do share the schematics. If we have a level of trust with them, we share the schematics so that they actually produce some of the hardware. How does it actually look like internally? It's something like this. This is the component inside on top of the hardware. This is for the FMUV6 standard. This is a high-level overview of how it actually runs. We got basically a bunch of IMUs on the top module. Has actually 3 of them. Has magnetometers, barometers. A heating element is important because sometimes you want to preheat the IMUs to be able to launch the drone. Has a secure element. Maybe you want to lock down the firmware so that no one can tamper with it. We have a micro SD card where you store the majority of things. Like I said, before. The RTOS is right there, running on top on the main microcontroller. And then on the other side, on the baseboard side, we have the Pixhawk autopilot bus with the PAB, the thin rectangle there. It's actually what's connecting both of the sides. It's like 101 pin standard that we published, and has connections for USB, Ethernet, serial, all of those things, CAN, and connects basically the FMU module with the baseboard. This way, manufacturers can develop their own baseboards, doesn't matter, as long as they support the PAV standard. All right, these are some examples of advanced compute modules that are actually running the flight controller plus something else. I'm going to start from the right. You got the NavQ Plus from NXP. Holy Rose Jetson 6X, which is obviously for a Jetson. We had Qualcomm RB5. And then the ARC Electronics 6X, which I'll already show you. These are the developer kits that I was talking to you at the beginning. The most affordable one is the one on the right. The Holy Brew one is like a $500 one. It comes pre-assembled to a certain degree. You still have to spend like about an hour. If you're really experienced, like 15 minutes, you'll get it done. But then it already has the cables wired through the motors, the ESCs, and everything comes together. But you do have to do the final assembly. And then you have a development kit. It's kind of big, but it's the most novel platform if you want to add extra sensors. They do share the layout so you can actually 3D print stuff on it and put like extra sensors on there. We've got the Model AI platform that's very capable. They have different versions of this, but the same hardware inside, but with different sensors, maybe a battery, maybe a bit bigger. And DroneBlocks also is another platform. They do educational software on top of this. So like drag and drop kind of editors for kids. They use this platform. All right, that's up to this point, PX4 and Pixhawk. We also have another project called MAVLink. So how do actually drones talk to the mission computer? How do you actually talk to the pilot? It's through a standard called MAVLink. So it's basically an XML file that describes different protocols. How does those protocols look like? A bunch of XML, of course. There's a very mature standard. It's actually being used outside of PX4, not just PX4 or DroneCode. There's other flight stacks that actually support it. Autopilot supports that. Also, private flight controllers that are not open source also support this. There's a lot of usage of MAVLink actually goes beyond PX4 or Pixhawk. The way this works is if you want to add the message here, you have to go through the development cycle. And if it's like a message that is already being used or deployed in a flight controller, they would help you put it in like common or standard or in minimal, like one of the official ones. But if it isn't used anywhere else, you go into development. So you can be sure that if you're using one of the top ones, it's going to be stable. But the development one might be a little bit newer stuff. How does it actually look like? Well, it actually describes the protocols of how to do things. I think this one is for mission. So if you have a waypoint system on the ground station, you actually define how many items are the waypoints, when a waypoint executes, what actually is going to be doing. Maybe you want to take a picture on a waypoint. So all of that is being described through MAVLink messaging. It's kind of boring, I know, but it's like the nitty-gritty details on how the connection between the drone and the mission planner works. There's a ton of sub-protocols in there. Chances are that you don't even need to touch this. It's already going to be working for you. But if you really want to work with MAVLink directly, there's an SDK. It's called MAVSDK. It's basically a C++ library that is using a gRPC connection to be able to have libraries in C++, Swift, Python, Java, JavaScript, so that you can actually build your own mission planning system or a mission controller application that is talking MAVLink to a drone. It's really cool. It has a plugin architecture. You can build plugins. You can have events interface, like, oh, when the drone reaches this distance, like, or does certain activity, notify this handler, and then it'll do that, trigger that. Error handling, shared vehicle control, which means that you can control multiple vehicles for swarms. And yeah, it's very widely available, documentation, tutorials, and all that. All right, so the other crown of the house, QGroundControl, which is the mission planning software, it's actually talking MAVLink, QGroundControl was made as a reference, this implementation of MAVLink, how to share the telemetry from a drone. It has everything that you can think of that can be streamed from a drone. It's inside of QGroundControl already. QGroundControl, it's right now in version 5. It's really stable. This is what pilots use. This is what, if a pilot is going to fly a drone, this is the app they're going to be using if they're using PX4. All right, what's cool about QGroundControl is, yes, it's open source. The name comes from Qt because it's using the Qt library. If you know Qt, that means that it's cross-platform compatible. You can push it to iOS, Android, Windows, and all that. It's Apache 2 licensed. It's supporting the newer release of Qt, I think it's Qt 6. And it can basically control everything. I think in the screen you can see it's like a very advanced mission, a surveying mission on a fixed-wing platform. As you can see, like the vehicle goes through all those missions, but it actually allows you to drag and drop and modify the behavior of the drone. So as a pilot, you can see this is very useful. This is actually something that we don't show often. This is the first version of QGroundControl from like more than 10 years ago. It went from this like ugly thing. It was using Google Earth as a imaging, and then went all the way to a tablet. So with this, you can actually not only control the drone, you can actually set it up. So when you connect the flight controller into QGroundControl, you can set up the drone. Like maybe you want to have a fixed wing, what type of multicopter, how many motors you have, what type of sensors, you're going to calibrate and tune all of those. QGroundControl allows you to do all of that. It also supports video streaming. So if you have a camera, it'll stream that back to the mission planning software. And yeah, that's the stack. I do have time for questions, but I want to talk about the latest release of PX4. Like I said, like I show you, we have rover support, way more hardware support. We support the latest gazebo simulator, improved complex calibration, better ROS integration, and more sensor supports. And if you can help us click on a star in GitHub, it will really help us. Yep, we have a lot of different hardware standards like that I've been showing. Where are the hardware? Who has the hardware? Here we go. Okay, cool. Thank you. I lost track of it. And yeah, just some of the latest release notes, I guess, for the projects. Lastly, before I have to go, I'm going to show you some research that I found quickly Googling or an archive that is using PX4. This is vision-based safe autonomous UAV docking with panoramic sensors. So they published a paper on how to actually do this with OpenCV and ROS and PX4. So basically what Mary did in the keynote this morning, some researchers doing this already. This is the Pegasus simulator, which is actually Isaac Sim beneath from NVIDIA, supporting UAVs. This is also another simulation using SLAM navigation. This is our micro vehicles doing a warehouse flight plan, again, the same as in the morning. Lastly, but not least, because I love space, as you could see if you went to my other talk yesterday, we do support spacecraft now, actually like controlling the spacecraft with PX4. This is research work out of KTH, and it's been merged to main already, so it's fully supported already. And if you want to take a picture of this, and I'm also going to upload the slides so you can get all these reference data. All right, so that's pretty much it. I think we have time for questions. Thank you. I'm a one-man orchestra, so I'm going to share this.
I can help out.
Yeah, I don't know how to turn it on, though, but it should have a switch.
Yeah, you're all right. It's good right here.
All right.
Hello? Oh.
All right. Thank you. Questions? Come on, that was a lot of information. It's a lot of information for not having questions.
Without a mic as well. This is my first that I see this. I'm not familiar with this, and great project, by the way, great stuff.
Thank you.
Is it also used in drone racing, and to what extent does that push the requirements for you guys as developers?
I would say that it's not being. I mean, people do race with this, but it's not the best project for drone racing. It is supported. I would say if you want to do drone racing, do what's the other project here? Betaflight. Yeah, use Betaflight. That's another project that is specifically made for drone racing. All right. Yeah, but well.
I can imagine that it places requirements and pressure on the architecture.
Well.
I was curious what that might.
It would require better telemetry on the motor size, on the ESCs, like D-Shot, but we do support that. Peter, do you have anything to say about that?
Yeah, so typically with racing, the additive controller is human, and with something with the Explorer, everything is controlled by software, so all the stabilization. And better flight, if you forget your troller, it just falls down.
Okay, so there's guardrails and more speed.
Yeah, I mean, there is research on doing autonomous drone racing, which is a bit interesting, but yeah, it's a bit slower than the human one. Yep, thank you.
They actually broke the. They actually were able to win from the world champion.
They finally went through the threshold?
Yeah, from the I think the autonomous perception group from also not
TU Delft?
TU Delft, yeah.
Yeah, of course. All right, any more questions? There was a few hands raised before. Yeah. No more? Okay, well, he changed his mind.
Does Pixhawk support rockets?
Rockets, yes, we do support rockets.
Yeah, it was not on the list.
I forgot about it. It's one of the things that you don't want to talk about, but yes, you want to talk about it, you know? I intentionally left it out, but it is supported. Anyone else?
Has anyone used it for rocket?
Yeah. There's research about it, and that you can find online, like actual research. Matt over there.
Hi, nice presentation. Is PX4 Flow still alive?
PX4 Flow? Oh, yes, the PX4 Flow, yeah, it is still alive. Actually, Arc Electronics just released a new version inspired on the Arc Flow. Yes. And then the older PX4 Flow is still around, although it's a bit older now, but it's still useful. Thank you. Anyone else?
How do you achieve this precision to formate, let's say, this figure with the drone?
With GPS, with RTK, it's like a lot of precision.
Okay. Thank you.
Yeah. Anyone else? Another Pierre? Okay. It's a loaded question again.
Yeah, so previously Pix4 was on NetXOS, and now I see that you want to move to Zephyr. So is that a full move, or you want to support both?
I think we want to support both. It's not been defined or settled that we're going to fully move to Zephyr. It's something that I am personally pursuing because they're moving towards certification, and I think that's something that's very valuable to us.
Okay, thanks.
Yep. All right, I guess that's it. Okay, thank you.